Okay, and we are live on YouTube. Welcome everybody to Advent of Code Day 14. Before I do Day 14, I wanted to quickly go back to something that I did yesterday, which was to finish Day 12. And I've written a lot of code, and more code, and more code, and more code. I talked yesterday about Amar today. Hello, welcome. Thanks for joining me on the stream. Nice to see you again after yesterday. So yeah, I fixed Day 12, which is just adding a cache, which is this code, and this is partly translated from a Python solution because I was figuring stuff out. But I adapted my code to generate a signature, which is generate a big signature, because if you haven't seen it, I wrote something to encode like the inputs exactly into one uint64, which means 64 bits of data. And I measured everything out, and that way it could be done. But for part 2, you needed to add 5 of them in a row, so you can't do that. So I created a new version that actually just emits ulongs as it runs out of space to go. So if the bit offset crosses the boundary, it will yield the result and then keep going. So yeah, this one can encode an arbitrary amount of data, which means occurrences and an input string, which yeah, I thought was really cool. So I used this for the hashing key, and then I expanded my existing collection, and this, I know this isn't pretty, but this just creates a tuple of 5, the 5 elements. And to do that, I actually extended my as extensions, which supports for reading past the length of the array. So if you do this and you feed in an array of say 3 items and you try to create a tuple of 5, it will just yield the default for the last values. I might want to switch this to like a switch where you explicitly say if you want this or not, but for now this was what I needed, so I changed it to be exactly that. And that allowed me to run part 2 like instantly and get the result. So yeah, that was nice. But yeah, today is day 14, so let's go ahead and tackle that problem. Parabolic reflector dish. You reached the place where all of the mirrors were pointing. A massive parabolic reflector dish attached to the side of another large mountain. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. Okay, this sounds like a complicated problem already. This dish must be what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors appear to be connected via an elaborate system of ropes and pulleys to the large metal platform below the dish. The platform is covered in large rocks of various shapes, depending on their position. The weight of the rocks deforms the platform, and the shape of the platform controls which ropes move and ultimately the focus of the dish. And in chat they say, you like bit operations even if it means going above 64. Yes. And the reason why I liked it for day 12 was because you have a giant cache that you're building up. So the smaller you can make that key, the more efficient and fast it will be. If it goes above 64, I would be too lazy to do it. Well, in the end, like, bits are just storage, and a ulong or an int64 is just a container. So you could actually just do it in bytes if you want and have a byte array. But I figured it would be more efficient to have the least amount of elements as possible for generating the collisions, etc. So that's why I did it this way. So yeah, in short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt it in one of 4 directions. The round rocks marked with a 0 or an O, I will have to copy that, will roll when the platform is tilted, while the cube-shaped rocks will stay in place, marked by hash pounds. You note the positions of all the empty spaces, periods and rocks, your puzzle input, for example, and then we get a map. Start by tilting the lever so all of the rocks will slide north as far as it will go. Ah, okay, so that's quite funny. You notice that the support beams along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. Okay. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge to the platform, including the row the rock is on. Cube-shaped rocks don't contribute to load. Okay, so the amount of load caused by each rock in each row is now as follows. In this total load is the sum of the load caused by all the rounded rocks. In this example, the total load is 136. Okay, I need to read that again. Okay, so 10, 9, 8, 7. Okay, so these are 4 of them. Hey, Smap UK, welcome and good morning. Let's see, so the amount of load caused of each rock, okay, is equal to the number of rows from the rock to the south edge of the platform. Okay, so the distance there, including the row the rock is on. Okay, cube-shaped rocks on computer. Okay, so you need to keep track of these. And the total load is the sum of load caused by all of the rounded rocks. In this example, the total load is okay. Tilt the platform so that the rounded rocks all roll north. Okay. So for me, I think you will have to go sideways after this or something, because this will. Or maybe it's like, how do you have to move everything so that it's all up there? Yeah, this will be a fun one. Let's see, Smab UK says, finished today, but I need to factor as it runs very slowly. Okay, so it's not a very straightforward problem then. Yeah, let's get started and code this up. Day 14. I'm not sure how I will do it yet. I think I will extract the positions of both types of rocks for now. Yeah, bool test is true in this case. If test input equals this. Okay. Let's see. Input dot 2 lines dot map, and this one will take const car round rocks, round rock marker. I like to add the word marker to the variable names, because that at least I know that I'm looking for a special thing that denotes it. And square rock. So we hash empty marker is period, but we won't use those. So we'll get the round rock marker and then the square rock marker. So the cool thing I can do now is far. This one will be, I think it will return 2 lists, right? Yes. It will return 2 hash sets here. And Mark today says, same here, Smap UK, my part 2 is notably slower. I already have some ideas on how to make it fast, I will try now. Okay, looking forward to see what you guys come up with in a bit. So this will be rocks equals like this. And I can actually do as, and this one will be x. Like this, I can just convert it into a value tuple here, and this one will be, so I will call this hash set int row int call yes. This one will be the round rocks, right? Yes, round rocks. I can just do round and square actually, like this. And I can put this up top here to make it available to the entire class. So now I have them, at least the positions of these parsed into 2 hash sets. To know where you need to go up. Like the naive approach would just to be stepping up and see if we hit something. I think I'll just do that for now. Actually, let me go and turn down the heating a bit. I just came back from the trainer, so I'm getting a bit hot, so I'll turn off the heat and come back in a second. Just a moment. Okay, so I noticed I started sweating because yeah, I'm drinking hot coffee and the room is warm and I'm still warm, so yeah, that was not a good combo. So yeah, move all the round rocks up. And I actually need to have the raw map probably. So let's just also do, no, actually I think it's string like this, string raw map. This is very ugly, so I won't do that. Raw map. Because I want to know like the rows and columns, so let's do int row count, call count, row count equals raw map dot length. Call count is raw map 0 dot length. Okay. And let me just make these uppercase because I have them here. Okay, I should probably also make this one nice in uppercase. Okay. So now we need to go through each round rock actually. So we can do yeah. I should probably go through them sorted because you need to go from top to bottom and try to move them up. So yeah, this will be a naive approach, but it will be fine. So we can do for each var round rock in rocks and round, order by x dot column, and then by x dot row. Okay, so we're walking all of the round rocks, and we do them column by column from top to bottom, right? And then we move them up. While rocks dot round contains basically we do round rock like this, and we need to have an extension for that, so we need to do int row int call up, and this will be val dot -1. So this is a simple, just move that one up, and this will be math dot min 0, boom, max actually, because we can't go past the 0. So we move up by decreasing the number, but yeah. And this one be, so let me just name this one here so that we don't have to call it multiple times. Position above, right? And the position above is up round rock. Position above. And this one is actually annoying because what we'll have to do is rocks.round.remove round rock, like this, so that it no longer exists. And now we try to move it up. And now we do round rock equals position above. Doesn't it let me, because it's a for each. Okay. But this won't work because the values will change. So no, this is correct, because this is starting out at each position and it will move as well as it will. So yeah, this is fine. So what we do is we have it ordered, then we take a snapshot of that, and then we process everything in it, and we will move up and we will compare against the real data. We just remove from the data set and then move it up. Yeah, this will be fine, I think. Okay, let me just do it like this. Var round rocks is this. For int I is 0, I smaller, come on, I smaller than, yes, plus I, like this. Okay, and then we can do round rock is no. I can actually use this one. Yeah, I need to have the variable here. Now do I? Okay, just do this is round rocks. Come on. Round rocks I. Then I remove it, and then I do this. And then I do this is up this. Now I can do oh no, because I actually need to have the double variables, because you don't want to increase it if it encounters something. Let me see. Smap says, I use a method which I sort of knew was going to be slow but looked nice. Okay, I know what I'm changing it to. Hopefully that is fast. Yeah. Okay. So yeah, let's do a round rock. Let's define it anyways. So I'll do it like this. Boom. I remove this one. I say this one is up this. Well, it doesn't contain, and then I do this is position above, and then I do position above is up rock like this. And then I can do if round rock dot row equals 0 break anyways. And now I can do rocks.round.add round rock. Right. In this case, it will boom. And I wonder if I even need to do this check, because what I can do is if rocks that round contains position above, like an initial check. If we know that we can't move, don't remove it and add it and do all that stuff. So I do a double check here, but it should save some of the other work there. So I think this one should actually move them all up. So yeah, let's just print out the map here. For int row is 0, row smaller than row count, increment row. For int col is 0, col smaller, yes, like this. And here we can do console.writeLine. If rocks.round contains row, col, console.write, and then we can do round marker. Else if rocks.square, square, rock marker, else console.write, empty marker like this. So this one will print out all our new state after we've run it. So just as a nice visual, and then we need to write the code to actually do the math on it. Yeah, I want to run this now. Oh, what happened? Boom, let me see. So this one should be about the same as here, except we are missing one marker. I need to check if the I forgot to check the square marker as well. So yeah, let's do that. Good point. Boom. So yeah, let's go back, because this one needs to also check. And rocks.square contains position above. Boom. So now if we run it, we should get the map that we saw on the website. Let me just do it like this. Does this match? I think so. Okay, so yeah, this works. This is fine for part 1. Let's calculate the sums now. So this is actually the inverse of the row times the inverse of the row plus 1. So let's see. So that would be rocks.round.sum. Let's call it R. And this would be r.row, and this will be the inverse. So row count minus this one. Yeah, so this will be actually correct already. Okay, wait, that's too easy. Int part 1 equals, and I already know, let's do long part 1. It's probably fine, but let me just do it this way anyway. And we do console.writeLine. Now write line. Part 1. Part 1. Okay. So 136, that is fine. Let's run the real code. And I should probably not print it out. So let me see, and then we do here if test, now we do the print, otherwise we don't. Okay, that completes instantly. So I wonder what the trick is for part 2. Woohoo! Part 1 done. Okay, let's continue to part 2. The parabolic reflector dish deforms, but not in a way that focuses the beam. To do that, you'll need to move the rocks to the edges of the platform. Unfortunately, a button of the side of the control panel labeled Spin Cycle attempts to do just that. Each cycle tilts the platform 4 times so that the round rocks roll northeast for us, and then, okay, let me see, go in the chat. Nice, Pratt, yes, thank you. I'm also happy that it worked. Each cycle tilts the platform 4 times so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. After 1 cycle, the platform will have finished rolling the rounded rocks, and those 4 directions in that order. Here's what happens in the example above after each of the first few cycles. Okay, so this is, why is this easy? Am I missing something? Ah! You need to calculate the total load of the north support after this many cycles. Okay, so the only thing that I can assume is that after a few times it will stabilize. So what we need to do is actually record a state after each time and then see when it stabilizes, and then see if we can extrapolate from that, I think. But yeah, let's see, this process should work if you leave it running long enough, but you're still worried about the north support beams. To make sure they'll survive for a while, you need to calculate the total load on the north support beams after that many cycles. In the above example, after that many cycles, the total load of the north support beams is 64. Run the spin cycle for that many cycles. Afterwards, what's the total load on the north support beam? Okay, I think that is fine. But now I just need to make sure that my logic works in 4 directions. So that is fine, but because to make this work, this sorting needs to be done properly. So yeah, let me just do void roll north. Let me just take all of this here and put it like this. And now I can just say roll north. Let me just get my answer from the last time. Okay. Debug with assert part 1 equals this. You broke part 1. Okay. I think it was 163, right? Let me see here. Yes, 136. Okay. So if I would do this and I do a roll south, let's just implement it, see what changes, then see if we can refactor it. I need to do this ordering, the column ordering is fine, but this one needs to be descending. So let's see, north, call, ask, row, desk, south, call, ask, row, ask. No, actually, I've switched these already. Great. And then check above. below. So this up then becomes a down, and this will be a min of plus, and this one will be a row count -1. Okay, so for south we need to check with down, and then down, next position. So basically we want to have a func here, get next position, boom. We just basically just twice this one and this one out. We need to have the int end value, which is 0 for top, end value equals 0, end value equals row count -1. So basically we need to have these, this is just an array, so we need to have these pre-ordered into the function, which is fine. Round rocks like this, boom. And I think we've abstracted away most of it, because this one then becomes get next position, get next position. If this one equals end value, then we break, and then we add it. And I think that this is it all. Roll, this is just roll abstracted, right? So roll north now just becomes this. Let me just move this away. And we do round rocks, not round rocks. It becomes this. Get next position is up, and end value is 0. And now we've abstracted away all of the logic, and now we should be able to do both of them. Boom, 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 boom. So roll south just becomes this now. Then by descending, and this one becomes down, and this one becomes row count -1. Okay, let's just make sure that this one is roll north, that it still works. Boom, it still works, so that is fine. Now we just need to do the other two as well. So we need to do a left and a right here. So left, right. This becomes val.row. And then we do this one with the column. Like this. Val.row. And the column becomes column like this. This becomes call count. Okay. So now we have those implemented. And let's just do north. Let's do west. This one will be 0. Yes, we move back. this one be left. And now we need to order by a different, we need to order by row and then by column. So yeah, we go left to right, so that is fine. And then we do the east one. East. So this one will be right. This one will be -1. And this one will be ordered by row. Let me see. Yes, just by row. And then by descending col. Okay. So I think this is the logic for rolling in 4 directions. Let's see, did we have a test situation after each step? 1 cycle. Okay, let me see. Oh, they show you after 1 cycle, so that would be, wait, north, west. So north, west, south, east. Okay. So let's do 1 cycle with the test and see how it works. True. So you don't get your intermediary steps, so you will have to figure it out. And this can just be a avoid print map. Boom. Like this. So now we do roll, so it's counterclockwise, right? Roll north, come on, roll west, roll south, roll east, print map. Like this. Okay. Let's just disable this one right now. Am I not running part 2? Okay, there's an infinite loop somewhere, I think. Let's run it and then pause. Okay. What is next position? So which one, let's see, we're in our call stack, we are rolling west. Okay, so we're going to the left. And the end value here is 0, that is fine. This needs to be a check, because this one needs to check the column and not the row. So this one needs to be like this. Bool is at end position and not end value. So now we need to do if is at end position round rock, and then we break. Okay. And this one becomes x dot row equals like this. Okay. This one is goal equals this. This one is 0, but this one will be the column, yes. Okay. So row column, this should be row, come on. Row column, row column, okay. Let's see, give it another shot, okay. Let's compare this to the text file here. after one cycle. Let's see. Boom, boom, 3, 1. We're missing one here. There's one here. We're missing one here. This is correct, and then we have one here. Okay, so it's not fully correct, which is annoying. Okay, I think it might be because I modified it for part 1, so I should not run part 1 because we need to reset. Part 1 to do reset map. Okay, so let's for now just not run part 1, just to make sure that I'm correct. Let's see. Nope, it's still not correct. That's annoying. Because this is a pain to debug. Okay, let's just print every step then and see if we can figure that out. Print map. Then we just do it after every step now. And this should let us figure it out. So this is the original state. Then it goes to here. Then it should go to the left. Let's see. So this one aligns here. This one ends up there. Yes, this one goes there. Ah, there's an issue here. So the order is not correct for the the sorting here. I forgot to do that on the other ones. Good. So let's see. We had north and south. They were correct, I think. So if we need to go to the right, we need to have the biggest numbers first. So if you go to the left, they need to go to the, like this, okay. Pretty sure this should be it. So let's figure it out and map it into the first cycle. Let's see. 1 there, 2 there, 2 there, 3 there, 1 there, 1 there, 1 there, 4 there. Okay, boom, that was it. That's good. Okay. So my question here is, does it stabilize? Because I think these are the same, right? Let's do notepad. Actually, I can just not bother here. Okay, let me do something. Instead of printing the map, I can make this string and I can do a build map. Let me just, I know this isn't efficient and I should probably do some binary encoding, but I kind of have a lot to do today, so I want to see if I can just do it quick and dirty for now, and then maybe revisit that later. So what I will do is string builder, SB is new blah. We don't need this one. So I need to do this. Append line. Okay, return SB.toString. Okay. So I can still do void print map console.right line. No, right line. Build map. Build map. Okay, so that still is functional. And now I just want to do, so let's get rid of these. For int cycle is 0, cycle smaller than 3, increment the cycle. Boom. String previous map, string.empty. Okay, so I can do var map is build map. If map that equals previous map console.writeLine. We can say new map in cycle this cycle +1 console.writeLine. Actually just print map like this. So let's run this. Okay, let's do this 10 times. Okay, it keeps changing. Okay. Hey Luke, welcome. Let's do this 100 times. I'm an idiot. So what I need to do, here it's map equals, no, previous map equals map. Okay, so it doesn't stabilize right away. Right? Or am I crazy? No, it shifts. Okay, let me just do it differently then. Let's do a dictionary of string int. Boom. Is new. Boom. And let's do if not, and we do previous maps that try get value map out in previous cycle. We do previous maps that add map comma cycle. Let's do this. Okay. Oh. Let's do it like this. Okay. So we have. Okay. So it doesn't stabilize actually yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So let's do this 1,000 times. Okay. So it stops after 9. Cool. Else console.writeLine. Come on. Where am I? Oh, I'm at day 10. Day 14. WriteLine. So we can say cycle is the same as cycle this, and let's do. I'm down to from 30 seconds to 2 seconds. Now that's good. Let me see cycle cycle. This will be previous cycle. Okay. So what is the pattern that emerges here? 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay, so the repeating pattern is 2 to 8. So once you can find this, you can also extrapolate where the next one will be. Okay, still a bit slow. Okay. So we don't need that many. Let's actually run the false. Let's not if test, then we do this. and otherwise we won't. Let's run the real thing 100 times. So I have a new map here, and after 97 it starts to cycle. Okay, so 100 is a little bit, so let's do 200 here. And then the stabilizing pattern is actually 97 to 95. So 97 to 95. So yeah, I've written code in the past to actually find patterns, but I don't know where I have it. So for now, I think I've solved this, which basically means I can just modulo this. Because we know like the first occurrence is here. Let's see, this is our loop. Stable loop. So I think I could get this down to like millisecond level fairly easy, but I'll have to change the way I built my key. So to actually figure out this one, it would be, how do I do this? So the length is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is 9 values there. So I think what I need to do is actually this minus 96 mod 9. We should, come on, go expected to see this pattern on iteration this. Okay. Int target iteration equals this. Let me just make sure that I can actually do this. So int tests is this, new int like this, and we do 100, 110. Okay, and I should probably do this for each var t in tests, and then I want to do t, then we do this, and it will be like this plus this, I think. So same here. And let's see, how many did I spit out? I did enough, right? Okay. So I have enough test data here so that I can validate my assumptions. Okay. Okay, let me see. So on 100, let's go back. For 100, we should see 91. For 121, we should see 94, etc. Okay, so we need to do pattern 91 and then do the answer. So my assumptions were right. So we do const, actually int target iteration is this. So actually it can do this. Okay, so we do, let's do this nicely. Int repeat at is 96. Int first repeat index is 87. Like this. So I think I will do it like this for now and then actually write the code later to manually find those. So it's 96. Oh, come on, let's put those here. 96. This is the first repeat index. And then int pattern length 9. And so the next step would be to just get those numbers programmatically instead of seeing it actually. Cycle smaller than repeats at, which is fine. And then here we would say actually I think if we stop here, we actually have the answer. Oh no, we need to have the target iteration, this one. We need to make sure that we do that one and end up in that state. And then we say part 2 is part 2. And we can't do this one yet. So yes, let me run this. Boom, and this should be our answer. Oh, too high. Wait. Let me first do the test. It should be 64, okay. Ah, for the test, it's all different data. Haha. Okay. Test is true. Let's see. 9 starts at 2, so it's 9 to 8. So let's see. See, repeats at 9. This one becomes 2. And the length is 8 here, right? 1, 2, 3, 4, 5, 6, 7. My bad. Okay. We don't care for these tests. 65, so it's off by 1 there. Do I need to do it like this? Am I off by 1 there? Okay, I was off by 1 because I don't need to actually do that iteration. So now we can go back to the real input. False. I'll do it like this. And now we should get the real input. Woohoo! It works. Nice. I like it. Okay. So yeah. Once we start to see this stable pattern emerge, and I wonder if we will see new maps until we won't see new maps, and then we will already be into the cycle. So I think we can do it dynamically now, actually. Thank you, thank you. Nice. So yeah, this was pretty cool. And now we just want to actually get those numbers dynamically. And then we need to actually go back and operate until the next one. We could also actually cache those values. So we can do int cycle, int result. That way we don't have to actually go back and run it again. Yes, so let's do that. Let's first do it like this, previous cycle, and then this one becomes this, add, boom, like this. Well, this needs to be along. It doesn't really need to be along, but I've made it along, so let's keep it along. So after this is done, we actually don't need to do this. We just need to have some sort of... actually, we could just do a while true loop because we need to find the repeating pattern. So yeah, let's focus on this. Like the first time this happens, we record the current index plus previous index plus offset, and we will know enough actually. No, that's not really true because we need to wait till we see, then keep going till we see the same index again. Okay. Okay, let's take away this handcraft values. So we do int repeats at is -1. First repeat index is -1. This one is fine. Pattern length -1. Okay. Uki. If repeats at equals -1, repeats at equals cycle. This is the first time we do this. Then we do first repeat index becomes previous cycle, that's cycle. And we do here else if previous cycle, that cycle is first repeat index. Okay, then we can actually break and we're done gathering all the data that we need. So now we can do cycle, no, pattern length equals, damn it. Would that be cycle minus first? No, repeats at. I think it's this plus 1, right? I will have to check this just to make sure. Yeah, and then we're done. We don't even need to do this one, and then we can break out of all of it. This will be yes, and then we get this one, and then we can say part 2 equals to this one will be previous maps target iteration dot result, like this. Okay, into string. Ah, okay, my bad. Where x dot cycle dot so I could probably keep a separate cache of like dot value dot no value. This one becomes single. No, that's not true. First, actually, just first dot value dot result. Okay, like this. Yeah, I think this is enough actually. So here pattern length is 2, cycle minus repeats at 0. Oh wait, what? Wait, what? Okay, I'm doing something wrong. Let me just check this here. Okay, let's see. If it's not there, if repeats at this is wrong. This logic needs to be in the else here. My bad. A little brain fart. Okay, let's run this again. And I need to break it here. Shit. Sheesh. Okay, so pattern length becomes 10. Okay, so this is actually cycle repeats at. So yeah, this doesn't need the +1, it's just this. Set next statement. Boom. So now it should print out the same as before, 537, is that correct? Let me see, that is not the correct one. Let me just make sure here. Like this, and this was like 64, I think. 2, you broke part 2. Target iteration. Let me see what it wrote up here. My values are repeats at is correct, first repeat index is also correct, pattern length is 9. So these are all correct. So do I need to have the next one or the previous one? So let me just check here. Yeah, okay, I need to have the one before it. Let me see. So if I do this, should be able to do this. Actually, no, like this, and then I can do a target iteration -1 to fix this. Because we're already indexing into the first repeat, so that should be fine. And that's how we actually solve it. Let me just time this, just for funsies. Just rudimentary, it won't matter much, but let's say stopwatch SV is new. Because I see people spitting out times, I need to do all the... Sequence contains no matching element. Nice! Okay. I broke something there. Bum, 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 bum. So, okay, let me just take this and see what I broke. Let me first copy this and then undo what I was doing. Let me see. Sure, but I needed to do this, actually this -1. Okay, I need to boom, boom, boom. Don't worry, 2 seconds is not a bar set high. Yeah, I know, but I'm just curious how fast this is because I haven't even optimized the way the cache works, because you could make that so much more, it doesn't run in, it runs in 0 time. I didn't start it. And this is with the debugger, so 0.6 of a second. Okay. It's not great, but it's fast enough. So yeah, I'm happy. So yeah, we also added the logic to pick up the cycle, etc. This was fun. I will probably clean this up a bit later, but yeah, it's nice that we didn't leave it with these numbers hard-coded, but that we actually took the time to just figure out those numbers. So yeah, I had fun today. Did you like it as well? Smash your kisses, it's about the same as mine. Yeah, but I haven't optimized this yet, so it could be so much faster. But yeah, because I think this map, just like printing out the this thing is so very inefficient. I could make this so much faster. And I might do that tonight. Usually in the evening I like to play around a bit more with it, but yeah. Do you want me to look at code? Let me see. You can post it in the Discord if you want. I know Smap's GitHub by heart, so GitHub. Let me see what Smap did for today. Ah, it's not committed yet. Okay. Amarth, how do I pronounce your name, by the way? Amarth Dea? Day? If you want to post your code, actually you posted it yesterday. I might be able to just see if you posted today. Yes, you posted it. Let me see. Not pushed it yet. Okay. Share your results tomorrow, and if you got it fast. Sure, I will. Let me see. Use large data. I like these attributes. Boom, boom, boom. Thanks for the thumbs up, Luke. Let me see. Move all in the direction. Yes. I also have a cache here. Cache hit. Let's see. Perform. Blah, blah, blah. What is the hash here? Ah, you take the input state, right? Ah, okay. Sure. I wasn't even smart enough to do that. I don't do that, actually. I just, I always do the action and then build the map. But I guess what you do is you take the map and then you just do the actual iterations and don't look for a repeating pattern, right? Let's see. Because you take the, I actually store the outputs and you store the inputs and then see if you have calculated that time already. So yeah, that's fine. This takes 2 seconds too long if I was to operate on proper mem representation and move up. Okay. Let's see, platform new lines, full swing. First time I hit cache, it means I have a repeat. Yes. Compute our way out so we don't have to iterate over a dictionary for X times. As we are in a cache already, we know nothing will change in terms of map permutations. No new results will be produced. We just need to compute which of our already computed results is the one. Okay. Okay. What you need to do is speed up the moves. Yes. Yeah, or you could actually, like the What I did was detect a repeating pattern and use that to just completely step over it. But yeah, you do the same here. You do the you do it in a different way, but it's also fine. Platform. Move all and move direction. While true, any move is false. For each move if possible direction. Okay. You use the, okay. Let's see the rock. It has a reference to the full thing, okay. Is movable, boom, 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 boom. Wait, sure. If not movable, return false. Is movable. Okay, you don't distinguish between, you just have all of them in the same, okay. I just kept separate indexes for the both rock types, and you just kept like each rock with their identity specification, like is it movable or not, with the reference to the full thing. So yeah, that's fine. Rock at dash is platform get at, and new x. Why is move to, how is that calculated? Okay, you have the relative paths here. Okay, sure. Okay, it's fine. I just have the time halved again, now under half a second. Okay. Okay, to the array, sure. Tilt 0. Okay, you have a tilt function here. Let's see, tilt. You keep them as chars here. So this is the 2D array that you parsed. Okay, so you clone the entire thing. Okay. Yeah, because you don't want to mutate your original data. That's fine. Direction, sure. Number of columns, number of rows. Wait, okay, sure. It's a fairly similar approach. Let's see, I think some of my code may be redundant now as well. Could be. Let's see the step. Sure. So based on which side you start, you do your step offset as well. So that's smart. Actually, does it always step in both directions? Let's see. Oh yeah, because you traverse. Yeah, sure. Now you have just two loops here. Yeah, I just took care of all of this with just having the data ordered. If it's a rounded rock and the next one doesn't have one, sure. So you have the same approach as me, like, okay, check if there's actually work to be done, then just keep moving along as far as you can and then update the data. So yeah. Okay, yeah, it reads pretty much along the same lines as what we did. So yeah, nice. Was fun today. I was worried that it would be a very tough day, but it's fairly easy. Just if you abstract away all the stuff, the amount of code that you actually wrote is not that big. So yeah, I had fun. Let's see what tomorrow brings. So for now, I want to thank everybody who kept me company. Luc, Amarte and Smab UK. Thanks for keeping me company. And